All right. You had the quiz yesterday. We don't have anything to check over. Those of you I know that weren't here or didn't take it because you had been gone the previous day, I did get some of your quizzes already from you taking it in study halls. Otherwise, your study hall later or advisory, depending on if you have a study hall or not. So your study hall teacher should have it, or your grade level advisor should have it, since you're going to grade level advisories today. Yeah, grade level today, because juniors and seniors have a survey they have to take. So that's why it's grade level today. Yeah, so grade level advisory today. Make sure you go to your grade level. So today, the next lesson in chapter 9, and then we are actually on Monday. There's not a new lesson on Monday. On Monday, we are completing or working through a Desmos activity that deals with compositions of transformations, what we're talking about today. So for this lesson, we have, first of all, kind of an example of what a composition of transformations would be. So it says footprints, or the pattern of footprints that are left in the sand after a person walks along the beach. This is an illustration of the composition of two different transformations. It's a composition of translations and reflections. And down here, I'll explain a little bit more as to why. But in general, when a transformation is applied to a figure and then another transformation is applied to its image, the result is called a composition of transformations. So when you have two or more transformations happening to one image, that's a composition of transformations. So the walking along the beach, the footprints left in the sand, that's an example of what's called a glide reflection. And a glide reflection is the composition of a translation followed by a reflection in the line parallel to the translation vector. So if you look off to the side here, I'm going to kind of color, and they are a little darker because on the actual diagram they were different colors. So these are if you're thinking of the actual footprints that are left, those are the actual footprints. But the idea here is that, say from this footprint to then this one over here, I could get to that footprint by translating this footprint up and then reflecting it over that line. So I could do a translation and then a reflection, and that would get me from here to here. And then same thing from this footprint to this one, I could translate this one up and then reflect it over. So from here to here, I could get to that through a translation and a reflection. And that's a glide reflection. When you have a translation followed by a reflection, that's a glide reflection. Think gliding, you're kind of moving and then reflecting. So what I just explained, the glide reflection shown is a composition of a translation along, and this stands for vector W. So remember, translations are along vectors, which shows you which directions to move and how far. And then it's followed by a reflection in line L that's drawn in there. So we are going to do a couple examples of glide reflections, A and B here. So we have, for both of these, we're starting with triangle PQR. We have the three vertices. We're going to graph triangle PQR and its image after the indicated glide reflection. So if we look at A, we have a translation along this vector and then a reflection in the x-axis. So I'm first going to plot PQ and R and label them. You can draw that triangle in. And then it's like you're actually making two images. I'm going to grab a couple different color pens here. So my first transformation is the translation along this vector. So Each point in my triangle, this vector tells me to move each point how far in which directions. So what does the -2 mean? Left 2. And then the 0 means that I just stay there. I don't go up or down. So the first number is left or right. Second number is how far up or down, in which case I'm not moving up or down. So I'm first going to move each of these points to the left 2. And this would be, you can label like this is P prime and Q prime and R prime. And I get this triangle then. And now I take that triangle and I reflect it in the x-axis, reflect it over the x-axis. And then that's going to be my final image that I'm looking for. So if I reflect P prime over the x-axis, it's a distance of 1 from the x-axis, so it would be here. And then how I would label this then, I would label it P double prime. That's what it would look like, just kind of 2 tick marks there. And that ordered pair is now at -1, -1, if I'm writing down my final coordinates of where I'm ending up. If I reflect Q prime, that'll now be down here. So that's Q double prime. And that's at, that ordered pair is 0, -5. And then reflecting R prime would be at 2, -2. So from the, on mine, with the different colors I used, from the orange to the blue, that is a glide reflection. I went left 2 and then I reflected it. And I gave the coordinates of my final image. Everything's labeled there. Any questions on that one? Okay, so then for B, we are starting with the same triangle. So if you want to sketch in again, P, Q, R, same coordinates from the beginning. So this one, we're translating along -3, -3, and then reflecting in y equals x. So our translation first, -3, -3, so we're going left 3, and then this -3 means what? Down. So left 3, down 3. Okay, and then actually for this one, because we're reflecting in the line y equals x, it might be helpful, and I'm just going to do it so that everybody in here can see this, but it might be more helpful to actually write down what these ordered pairs are, even though these aren't my final. So P prime right now is at -2, -2. Q prime is at -1, 2. And R prime is at 1, -1. And now when I do my reflection in y equals x, what happens to my ordered pairs when you reflect in y equals x? The coordinates switch. So that's where writing this down for this one might be easier, because now I can get the ordered pairs and then plot them. So now P double prime, that is actually going to be the same as P prime, because if I switch them, I still have -2 and -2. Q double prime will be at +2, -1. And then R double prime, if I switch those, I have -1, 1. So P double prime is the same as P prime. And then 2, negative 1 is Q double prime. And negative 1, positive 1 is R double prime. So these second two that you're drawing are very overlapped here. But that would be the glide reflection. So translating left and down 3 and then reflecting it in y equals x. Okay, so just combining transformations you've done before. Any questions on those two? Translation followed by a reflection. Okay, so then I have here the composition of 2 or more isometries is also an isometry, which this it was a question I asked you on your review. We talked about this word on the very first day of chapter 9, the very first lesson. So anybody remember isometry, what that is or what that means? Yes, they are congruent transformations or a congruent transformation. The 3 transformations we've been doing, reflections, translations, and rotations, are all isometries. They are all congruence transformations. The image is congruent to the pre-image. So this is saying if you compose 2 or more of them, you will still have a congruence transformations. Your ending image is still the same as the original image. So we're not, you shouldn't end up with anything that's a totally different shape than what you started with, or a different size if you do something isn't right. So example 2, this is saying the endpoints of segment CD are, and it gives us those 2 points. So it's just a segment, graph segment CD and its image after a reflection in the x-axis and a rotation 90 degrees about the origin. So now we are reflecting and then rotating. So I'm going to plot C and D. So it's just a segment. And I'm going to do the reflection first. So I'm going to reflect both of those points over or in the x-axis over the x-axis. So this would be C prime. This is D prime. And again, it might be helpful. I'm going to write this down, what C prime and D prime are. So C prime now is -7, -1, and D prime is -3, -2. So now I have to remember when I rotate 90 degrees, what that procedure is. So if I start with a coordinate x, y, what are the coordinates of the image? How do the coordinates change? Yes, so the y is negative and then they switch. So it's -y followed by x. That table was on your quiz yesterday. You didn't have to memorize that. So then I would do that to these points. So my C double prime will be +1, -7. And my D double prime will be +2, -3. So C double prime's down here. And then that's D double prime. So this is my ending segment after I reflected and then rotated it. Okay, questions there? Just keeping track of your transformations, and if it helps, like we did for the last two, if it helps to write down the ordered pairs of that first transformation and then get the ordered pairs for the second, do that. I'm showing you that in case that's helpful to you. I find it helpful. You might also. Okay, so then on the back of this, this is showing compositions of multiple reflections and how they can be described. So we just looked at how, or the first two were glide reflections. That's a specific composition where you have a translation followed by a reflection. This is saying if you have the composition of two reflections in parallel lines, this is the same as a blank. So if you look at this picture here, I'm starting with this triangle, reflecting it over line K, and then reflecting it again over line L, and I end with this one. Anybody know what singular transformation we could describe two reflections as, Jocelyn? A slide, which is also a translation, yeah. So this is the same as a translation. If you reflect an image twice over two parallel lines, you will get what could be described as a translation. It just looks like it was slid to that new spot. Then the next one, the composition of two reflections in intersecting lines is the same as a blank. So here we're starting with this segment with point A. It's being reflected over line K and then reflected over line L, where K and L are lines that intersect. So this is where we're ending. So what transformation could we describe two reflections as if the lines intersect? From here to here. Isaac? That is a rotation, yes. Okay, so some compositions of transformations can be described as just a singular transformation. So these next two are just having you kind of show this or visualize it. So example A, well, these both say reflect figure A and B in line N and then line Q, and then describe the transformation. So if I reflect this smiley face over line N, I'll get a smiley face that's upside down. And then if I reflect it over line Q, it's back to being right side up. So that's an example of that first case. Lines N and Q are parallel. So reflecting over parallel lines, we could describe as just moving that smiley face down to that new spot. So I'm going to put a little more detail here. I'll say reflecting over two parallel lines is a translation. And then B wants you to do the same thing with that part. Reflect it over line N first and then reflect it over line Q. So here's line N. I'll do my best to draw what that part looks like here. If I reflect over line N, and now this is line Q. I'm going to turn my paper here. Can't draw hard upside down. It's going to look like this. So you're thinking from this heart to your very final one. So that could be thought of as it's being rotated because it was two reflections over intersecting lines. So I'll put here reflecting over intersecting lines is a rotation. All right, and then this is just going on to show that many patterns that you normally see, you can start or you can describe or hopefully see compositions of transformations. Like this one here, what composition of transformations would you describe that as, that pattern as? A what reflection? Not a guided, a glide, yes. So again, if you think of moving this leaf over and then reflecting it, this would be a glide reflection of the leaves. If you look at, these are described as carpet patterns, but it could be like a pattern or an emblem for anything. What transformations do you see in that circular pattern for A? Alex, what did you say? Rotations. So this is probably just a series of rotations all the way around. You're continually rotating that diamond shape in there, or that kite shape. Should describe it more as a kite. What about B? The what? The glide reflection. So if you move the white over and then reflect it down, or same with the move the black square over, reflect it down. All right, so your practice will be not only practicing the composition of translations, but maybe also recognizing what transformations are happening within a specific pattern.